This video presents an easy tracing problem for arrays. On the next screen, you'll be presented a problem and a space to write your answer. Afterwards, we'll go over the problem and see how you did. All right, so let's go over this. So first we have our command window workspace. So let's label it like that. And we're creating an array called A. And this array, the first row will be 1, 2, 3. The second row will be 6, 5, 4, and the third row will be 0, 0, 0. All right, and then we're passing this array into our myfunc. So we have another workspace for myfunc. And we're passing an A into the variable array, or R. So we have 1, 2, 3, 6, 5, 4. Oh, let me write that here. 6, 5, 4. And 0, 0, 0. Awesome. So now let's look at our first line of code here. So on the right-hand side, we're saying array of end minus 1 here. So remember this syntax. This is just going to evaluate to one number. So since we're just using one number here, we're indexing using linear indices. And so end is the last element using linear indices, right? So that's the 0, this last 0 here. And it says end minus 1. So we're going up 1 to the 4. So on this side here, we have 4. And we're placing that inside of the array at the third position. So the third position is this 0 here. So therefore, this 0 is overwritten, and it becomes a 4. All right. Let me put some commas in there just so it's a little clearer. Okay. And then so on the next line of code, we're taking the sum of our array. So remember when we use these mathematical functions on arrays, by default, they work down the columns. So A in this case will be a sum of each of the columns. So we'll have a vector. And so, let's see. So the sum of the first column, we have 6 plus 4 is 10, it's 11. Then we have 5 and 2, which is 7. And then we have 4 and 3, which is also 7. And then in the next line of code here, on the right side, we have some concatenation going on. We know that it's vertical concatenation because we have the semicolon. And so this part right here, we're using the row and column method of indexing. And this is specifying the row. This is specifying the column. So this is saying the last row, all the columns. So the last row in all of the columns is the 4, 0, 0. And then we're vertically concatenating that on top of our array. So essentially what we're doing is we're taking a copy of the last row and sticking it on top of our array. So therefore our array changes. I think I'm just going to rewrite it. So this changes. I'll just rewrite it down here. This changes to be, so we're concatenating our last row on top, so we have 4, 0, 0. Then we just have our original array. So we have 1, 2, 3, 6, 5, 4, 4, 0, 0. Awesome. And then this last line of code, let's start at the inside here. So remember, this is shorthand for saying array from 1 to the end. And since we don't have any commas and we're not using row and column notation, this is using linear indices. So this is saying I want all of my elements using linear indices. So I'm getting out all of my elements, and it's going to come up as a vertical vector. But in this case, this doesn't matter because we're just taking the length of it. So this is just taking all the elements, putting into a vertical vector, and then counting how many there are. So it's just asking how many numbers are there in our array. And so our array is a 4 by 3, so we can just multiply that. So we know that there are 12 elements in our array. And so B would just be 12. And so we get to the end, and we do this translation of outputs, remember? So A goes into out 1, B goes into out 2. So therefore, inside of our command window, or not A, sorry. Out 1 is whatever A was, which was 11, 7, 7. And then out 2 is whatever B was, and B is 12. And so that's it. So those are the two answers it asked for. So out 1, 11, 7, 7. Out 2 is 12. And that's it.